Selecting entries with SQL based on a hierarchy of rules is one of the most common intermediate interview questions, and a task you'll solve regularly once you land a job as a data engineer, data analyst, software engineer, or literally anyone working with data. Whether you're prepping for interviews or just want to sharpen your SQL skills, you're in the right place. Let's look at the two real-world ways to do it. I think the best way to understand and learn such concepts is through real-world examples. And with that, let's look at the first problem that we have here. So we need to select top 3 relevant reviews per product. Here you can see a simple example with entities. Basically, we have products, and each product can have many reviews that users left for it. And our task is to come up with the relevance score and select the top 3 metrics based on the relevance score. By relevance, I mean the combination of different dimensions, different metrics that review has to select the most useful reviews, because review with highest score doesn't mean that it's the best review, or review with just longest text also by itself doesn't mean that this is the most helpful review. And here you can see the metrics each review has. The rating score, whether it has image or not, the amount of words in the review. Helpfulness score means basically the upvotes that the review received from other users, basically just an integer number. And a review date when it was left. So with that, we have all the information to solve the task. Let's open the editor and just do it. Here I have some sample data that we are gonna use. Let's quickly look at it. It's kind of a denormalized table. It has product ID because we want top 3 relevant reviews per product ID. For example, here is an ID product with ID of 1. It has 5 reviews with different ratings, different property, different values for has image or not, helpfulness score, review date, and word count in each review, and the same thing for our product number 2. Alright, and the first thing that we need to do is to come up with this relevant score with weights, and here is how we are gonna do it. In our next CTE called scored reviews, we are gonna do the following. We are selecting all columns from our initial CTE or table and add the calculation for the relevant score. And here is how we are gonna do it. So first things first, we are gonna multiply the rating by 5. Why 5? Don't ask me, that's just a weight that I came up for the rating, because a rating score is important, but this is not the dominant factor, because as I said, the fact that review has 5 stars, it doesn't mean that this is the most helpful review, but we still want to kind of promote the more positive reviews. Another thing, whether it has image or not. So if the review has image of the product, we are gonna give it 10 points, otherwise 0, because it's nice if reviews have. Next, word count divided by 20, because the idea is more words we have, the better, the more detailed review is, and chances are higher that it's a decent helpful review. Helpfulness score is the amount of upvotes that the review has from other users. The weight is 1, so basically we just take the number of direct votes. And the last and the least important metric is review date. So basically we favor more recent reviews. So we use a dateDiff function that takes the current date when we run the query and subtracts from it the review date. And then we multiply the value by minus 0.1. Basically, the bigger the difference, the more negative score it will get. And then we just do a sum of all these values here. And finally, as we have a relevant score now, in the next CTE, we will use row number window function to rank reviews per product based on the relevance score. If you're not familiar with window functions, I suggest you learn about them separately, but super quickly and overly simplistic explanation of what's happening here. Basically, we say SQL to partition by product ID, and within this partition, so basically within, for example, all records with product ID 1, we want to order based on the relevance score in descending way and apply a row number. So basically the entry within this product ID 1 that has highest relevance score will receive a row number 1. Then 2, 3, 4 and 5, because we have 5 entries per product ID 1. And the same logic applies to the product with ID 2. And then finally we have a select all columns where row number is less than or equal to 3, because we want only top 3 relevant reviews. So let's run it and look at the results. So here we have 3 entries per product ID 1 and 3 entries per product ID 2. So review that won for product ID 1 is a review with ID 101. It has a rating of 5, it has an image, it has a lot of words, and it has, I would say, average helpfulness score. And by combination of all factors, it received the relevance score of 3.6, and it's relevant enough. And for example, for product ID 2, the most relevant review was 203. With the rating of 3, it had an image, it had 40 words, and a very high helpfulness score. So I guess this was the most crucial factor here for this review. Yeah, so this is the first approach how we can solve such problems by coming up with a fictional score with weights per each metric, and then summing it together and applying ranking window function based on this score within the partition. And like that we can select n relevant records per product ID or whatever you are calculating. You can apply this logic to other scenarios as well. And now let's look at a second problem that is a good example to demonstrate a second approach to selecting rows based on hierarchy, but in a slightly with a slightly different goal. So this was actually a task I was working on during my day-to-day job, and it was when I came up with the idea to make this video. So problem number 2, the duplication of emails, and here we want to select best entry, so only one best entry and not top n as in the previous problem. For this one I'll have to give you a bit more context, since this one is literally coming from a real world. It was around the marketing and marketing data. So we have a table that has leads and contacts. Lead here is a marketing lead, basically an email that was somehow gathered, maybe through the landing page, through some form or whatever. Basically, user gave us their email and it was entered in the system. Also, this table has contacts, and contacts are related to accounts. Account here is like a company account. So basically, this is an entity of the company. Each company has an account. And one account can have many contacts. Leads are not directly related to accounts. And contact is basically just an entity for the user that is tied to their account, meaning that some salespeople can open an account page of the company, see which contacts have been added to this company, and then maybe pick up someone from contacts and call someone. Lead can be just a marketing lead, so it can stay just an email, or it can be converted to the contact. For example, a lead email was gathered or inputted in the system by some person, and then someone else called the guy and asked him, hey, do you work at this company, blah blah blah, then some communication, and in the end lead was converted to the contact and assigned to some company account. Yeah, and our source table basically has leads that remain just leads, not converted to contacts, and leads that have been converted to contacts. And also our table has pure contacts, so maybe someone just opened the system and added someone as a contact of the company, but not from a lead, but in some other way. They knew their information, they got it in some other way, and just added a separate contact which was not coming from the lead. I hope I explained it more or less clearly, but if you didn't, I'm sorry. This is like as I said, a real world example, and it's a bit hard to explain all this interconnected logic. And again, don't be surprised that everything is stored in the one table, because this is the table for data analytics, and it's a common thing that we have a denormalized table with a lot of different information in one table. Leads, contacts, and just leads, just contacts, everything in one table. It's fine. And we have a problem with such tables that it stores duplicates of emails. Basically a data quality issue, and our goal is to fix it. So our task is to deduplicate email by selecting the best entry according to the set of rules. In the end, we want to have one best entry per email address. I think it's clear. So now let's get back to our SQL editor and look at the second example. So let me run the query with test data, and let's quickly walk through it. 6 records. So first one, John Doe, and it's the scenario number 1, a lead that was converted to a contact plus a duplicate lead. So the first entry is the lead that was converted to a contact. How can I say it? Based on the contact ID, because for pure lead that was not converted to a contact, it's null, and the account ID also is null. By the way, profile contract type also should be here null, but yeah, you can just ignore it here. Let's quickly look through other columns that we have. So lead, contact, account ID, profile contract type, so basically like a plan that the company that this guy is assigned to has. So pro plan would be something that they pay for example, and trial is free one. Account parent account ID and account parent top account ID. This is basically the part that I forgot to explain, that company accounts have relation to itself. Basically, there can be one company, and there can be a parent company of the first company, and there can be another parent company of this parent company of this child company. And these two columns are a way to access the direct parent of the account or the top account in the hierarchy. So for our guy here, both of them are null, and it means that this account that this guy is tied to is actually a top account in the hierarchy, or maybe it was just one company without any parent company. Okay. And another column that we have here, account primary contact ID. as I said, one company can have several contacts, and we can mark a certain contact as a primary contact for the account and create it on basically the date when the entry was created. Second scenario is a duplicated contact where we must choose based on hierarchy. Actually, this girl is not tied to any lead. This was the case that, for example, someone entered this contact for account manually created it. And the last scenario, just two unconverted leads, basically a data quality problem here. So now that we know the data, let's look at how we can fix this duplicates logic. Again, we are gonna use our powerful row number window function, but without the score, because in this case, we actually don't need it because we have a strict set of rules. If this, then choose this. If that, then choose that. And in that case, we can just use row number here. So what are we doing here is selecting everything, then adding a new column row number, and in that case we partition by email because our goal is to remove duplicates per email. So we partition by email and then do the ordering here. So first rule is contact is more important than lead. And we do that with the case when statement. So basically when contact ID is not null, then we set the value of 1. Otherwise, we set it to 0, and then the ordering here is in a descending order. So basically, if we have contact ID not null, this record will receive a row number of 1. So between these two, with that rule, we already eliminate right away the second row later when we will filter it out. So this row will have row number 1. Second rule that we have, for example, if it's still a tie, because there is no guarantee that in the real table there will be like only 2 duplicates, there can be more. Second rule is about the contract type. Basically, we want the entry with a higher contract type first. So we want to keep it. The profile contract type can be trial, basic, standard, and pro, the highest one. And we here use again the case when statement. If you're not familiar with it, it's basically just an if statement. So if contract type is pro, then we set the value of 4, the highest score. If it's standard, then 3. If it's basic, then 2. If it's trial, 1. Or otherwise, if we have this value as null or whatever, or something else, then the value will be 0. And again, we have a descending order here. So that would be a second rule. Basically, if the first rule didn't help us, then we rely on the second one. If it's still a tie, then we have a third rule that says us that we want the highest account in the hierarchy of account. So if we have a child company and parent company, we will want a record that is tied to the parent account ID. And we use here again case when statement. So if account parent account ID is null and account parent top account ID is null, then we set 1, otherwise 0, because when both of these values are null, it means that the account is highest in the hierarchy, or it's just one account that exists. If it's still a tie, then we have a fourth rule, primary contact first. So it's about this column. As I said, people can mark contacts as primary contact or not primary contact, and we use case when statement here to compare the account primary contact ID that would be coming from accounts table to the contact that we have here, and I mean this. this column. And if it's a match, then it's good and it's the primary contact. Otherwise, 0. Yeah. And sorting in descending order. Finally, the last rule, we want most recent records. That's a final tiebreaker to resolve it. So that's based on the created on column, and we want the latest entry. Based on these rules, we would create a row number per within each email, and finally just select one row this time with row number equal to 1, the record that matched our criteria the best. And as you can see, here we have it. So for John Doe, it was our first guy that lead converted to contact, and I think it passed based on the first rule. Jane was a duplicated contact, and if I remember correctly, she won based on the contract type. And the last guy, Peter Pan, I think he won again on the profile contract type with a entry with the basic contract type. And this is it. We solved our second problem, the deduplication of emails, and selected one best entry per email. With that, you now know 2 approaches of how to select records based on the hierarchy of rows, whether with the score approach or just selecting best entry based on a defined strict list of rules. I hope this video was helpful to you, and now you have the tools to solve such problems during the interview or during your day-to-day job. In the video description you'll find the links to the GitHub with the code snippets that I used today. I highly recommend to you to open it, to copy that code into the SQL editor and to practice with it, to play with it, to understand these 2 approaches better. If you're interested in more content like this, subscribe to the channel and I'll be very happy to have you here. You'll find a lot of videos about SQL, interview preparation, software engineering, data analytics, and much more, even the tech book reviews. So there is and will be plenty of things for you to enjoy. YouTube thinks that you might like this video. Give it a try and let me know what you think. With that, thanks for watching and happy coding!